All right. So you've just done this warm up here about resident versus non-resident, and this one maybe was a little bit different because I didn't make the difference 0 where I had been kind of doing that before. It's not a big deal though. I mean, you could still use the calculator to do it. So here I have the true mean difference of tuition, and I have non-res minus res. I had already calculated the mean and standard deviation for you. And we want to know if it's $5,000 more. So I want to know if non-res minus res is greater than 5,000. Okay, so I go through here and I conduct that. Remember, it's a matched pair, so I'm just using this t-test here. I can use the stat option. I'll put the 5,000 there. I'll put the 7,028 here. The 6,017 and 23 here. Sample size was 18, and I want to know if I'm greater than that, okay? There's my test statistic, there's my p-value, there's my inputs, and again the p-value, so I was using I said up here let alpha equal 0.05, so my p-value is greater, so I'm going to fail to reject. There's not enough evidence to say the true mean difference in tuition is greater than 5,000. Okay? All right, this next section right here. What we're trying to do is we're comparing confidence intervals and significance tests. So when we do a significance test, we have, basically we just get a yes or no answer. So like, so we get a result and we reject HO or we don't reject HO, but all we know is it either is different or it's either is different or we can't conclude it's different. We just get a yes or no. But a confidence interval actually tells us a range of values, so it gives us numbers that it could be. All right, we did this example already. We did this example in 9.2, in your 9.2 notes, page 4. So quickly reread this example here. Again, pause the video. Like I said, back in 9.2 notes, page 4, we did a significance test. We tested this HO against this HA. And we ended up with the conclusion of we were going to reject. So all we knew was that the true proportion was different from 0.31. But we don't know what the actual proportion is. So if we created a confidence interval, we could actually get an answer to that question. So let's create the confidence interval here. So I'm only having to do steps 3 and 4 here. You can use the formula if you want, or I can go to stat test, 1 prop z test, nope, stat test, 1 prop z interval. There's the 68, the 300, 0.95, and I get this interval right here, okay? There's my p hat, and there's my statement there. So my point here is that what if we did this first and we didn't do this? Could I still answer this question from this confidence interval? So based on the interval, should the company be investigated for fraud? So remember back here, up here it says if the proportion of first digits that are 1 is significantly different, then they should have a much thorough investigation of the company. So based on the interval, this is what we think P. So we think P is somewhere in this interval. So should the company be investigated for fraud? Yeah, because 0.301 is not in that interval. So it's not a possible value, so the company definitely should be investigated. So not only was I able to answer this question, so I'm rejecting HO because it's not in here, I also have an idea of what the value is because it's somewhere in between these two numbers here, okay? So basically here, so a two-sided, remember two-sided could also be called two-tailed. or so that's your not equal. So that's when your HA has the not equal to it. So a two-sided test at a significance level alpha can be carried out directly from a confidence interval with the confidence level 1 minus alpha. So what I'm saying here, so back on this problem right here, I had a confidence level of 0.95. There's this relationship right here. So that would make my alpha 0.05. So I can carry out this test from this interval at the 0.05 level. So when you do, this is for the proportions, so that you have that number there. So if your number is outside the interval, then we reject HO. So in this case, that P equals 0.301 is outside the interval, so I can still make the conclusion to reject. If I did it for the mean, I would just look at that number. If I'm outside the interval, then I'd also reject HO. All right, again, you know the drill. You should be pausing the video and trying the problems on your own and not just thinking to myself, hey, I'll just look to see what she did because I know what I'm doing, and then come test time, you find out you really don't. So, you know, that's all I'm saying. So you do this problem, you get this interval. Based on the interval, is there good evidence that the proportion of teens who pass their driving test in the first time is different from 0.6? So it's like I'm testing P is equal to 0.6, P is not equal to 0.6. So unfortunately, I know it's close, but 0.6 is not in that interval. So I would reject that P equals 0.6 and conclude the true proportion of teens who pass their driving test in the first attempt is different from 0.6, so I'm concluding that. So let's say I carried out the test instead. So let's say I went here, so instead of doing the interval, and let's say I was carrying out this test using these numbers up here. So I'd have 0.6 here, 86, 125, not equal, calculate. So here you can see there's my test statistic and there's my p-value. So yep, this was a 95% confidence interval. So if I use a alpha of 0.05, that p-value that I got is less than that, so I would still reject HO, which is the same thing I'm saying up here, okay? Again, like I said, we can do the same thing for the mean. All right, so again, here we go. Pause the video, attempt the problem. This is what you should get the answer. Just make sure you know it said normal, it says SRS. Okay. Is there significant evidence that the subjects did not gain 16 pounds? So this is like testing. Mu is equal to 16. Mu is not equal to 16. Is 16 in this interval? No, it's not. So, like I said back here, if the mean is outside the interval, we're going to reject. So here I am. I would reject HO, and I would conclude that the mean is different. So yes, 16 is not in my interval. So at the 0.05 level, again, 1 minus that, I can conclude the mean weight gain is different from 16 pounds. All right, last thing. This is just some fun problems there. All right, so we get a p-value for a two-sided test. Remember, two-sided, two-tailed, not equal, okay? That's the HA is not equal. So the null hypothesis was mu is equal to 10. This was the p-value that was obtained. So that's the probability of getting that sample value or something more extreme. This is my HA. So does the 95% confidence interval include 10? Why am I not? So the 95% confidence interval would tell me I'm using an alpha of 0.05. So here's my p-value. If I compare that to alpha, my p-value is going to be greater than alpha, so I'm failing to reject. If I'm failing to reject, then the number must be inside the interval. So yes, 10 is in the interval, as I would fail to reject at the 0.05 level. Now I'm talking about the 90%. Alpha is 0.1. So here again, now I'm going to reject. So if I'm rejecting, it must be outside the interval, so it's not in the interval. All right, this next one. Again, pause, attempt, come back. All right, p-value for a one-sided test. It says one-sided. I don't know which way the one-side is. It could be this or it could be this, but I told you back here we were only supposed to do the comparison when we had a not equal. So I got to do something here. So what I'm going to do is I'm going to take that p-value and I'm going to double it. Because think about it. I don't know which side this one-sided was, but let's say this is the p-value. And this is what the test statistic was. Well, if you're two-sided, all I told you have to do is just you find the other one, and this is going to be 0.04, so I'm going to double it to get 0.08. Now I can answer that question. So here I'd fail to reject, and yes, 30 is an interval. The other way you can approach this problem is keeping the p-value as a one-sided, but instead of comparing it to the original alpha, split the alpha in half. So compare the p-value to the half alpha. You'll still find it's greater, so you'd still fail to reject. Same thing down here. I'm using that two-sided p-value, comparing it to the 0.1. I'm going to reject here, so then it's not in the interval, it must be outside the interval. Again, alternatively, you could take that alpha, split it in half, and compare the p to alpha, and you'd still make the same conclusion. For this one right here, what I did here is I just found the interval. And then no, 34 is not in the interval. I'm sorry, 34 is in the interval, so I'm not going to reject them. 36 is not in the interval, so I am going to reject. Okay? This one is just, I think your packet's corrected, but it should be just 86. All right? And that is it for chapter 9.